Alright guys, welcome back to another in-depth SAT reading guide. Today we will be analyzing passage 5 of SAT practice test number 2, which will be a science passage. As usual, we're going to be first scanning the passage, and then summarizing it, and lastly, finding evidence directly from the text to prove or disprove an answer choice. Now, let's get into the passage. Okay, so we know that this passage is called Long Mystery How 500-meter high undersea waves form is revealed. Very, very long title, typical of a science passage, right? Okay, so some of the largest ocean waves in the world are nearly impossible to see. These are called internal waves, okay? Do not ride surface, okay, underwater, blah, 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 blah. Okay, but while they're invisible, they're still very fundamental to ocean water dynamics. Okay, that's about it for that paragraph. Because these waves are involving ocean mixing, transfer heat. Okay, so crucial to climate change model, global climate modeling. Okay, that's what the perspective of researcher, so probably Professor Peacock. Most model, okay, blah blah blah. So if you want, so that signals a motive. Say motive here, motive. Okay, so what's his motive? To develop more accurate scientific climate models. Okay, let's go into the next paragraph. So they try to do just that. So I think just that would go back here. It was like to develop, to understand processes such as internal waves. Their study published, okay, focuses on internal waves at this location. Okay, so this is the waves that they're looking at are some of the largest in the world, 500 meters high. That's pretty tall, I would say so. Next paragraph. Know that, okay, they didn't know exactly how. So this is something that they didn't know before. So they didn't know how. That's what they're trying to find. And to accomplish this goal, they utilized, okay, the Cornelius platform. Great. And then talks a little bit about how this instrument works and how they could use it to do simulations of ocean stuff. Okay, next. Peacock and his team, carbon fiber, and they fancy. Okay, okay, then, okay, small particles, finally. Okay, so all of these, procedural words tells me this is like a list of the steps that they use to, like an ordered list of the steps they took to recreate the environment and what they did to study it further, right? Okay, so distinct. Okay, turns out to be responsible. Okay, so this tells me that this is like their conclusion. What they found during their research. Well, they found, what did they find? That, okay, so tides rise and fall, moving through the strait. So the colder, dense water is being pushed over the warm, less dense layer. Okay, I'm just gonna underline it because I probably can't remember that like during the whole test. So we're gonna probably need to come back to that later. And okay, a bunch of other stuff about the inner workings of internal waves. We're gonna come back to that later probably because I don't think it's like easy to memorize all of this detail, right? The researchers were also able to devise mathematical model. Okay, this model is specific to this, but okay, so it could still help you understand how internal waves in general are generated in other places. Okay, and lastly, going back to a little bit about that global climate thing earlier, it's going to be incorporated in global climate models, making them more accurate, and that's about it. So let's go back and just give a quick summary of each paragraph. The first paragraph serves basically as a definition for internal waves. Let's just write that down. So this is define internal wave. Internal waves. Okay, next. This is gonna be starting from here. We take our focus to Professor Peacock, and Professor Peacock's motive is stated here, so I think that's good enough. And then the next paragraph, starting from here, we start really diving into his research, right? This whole part is talking about a little bit about the background, where the location is. Let's just write location here. Okay, and then describes a little bit of the technology they used, right? And then over here is a little bit of the steps, what they did with the technology. And then the next paragraph talked about what they found after they followed their steps, right? A very typical research essay. And then the last one talks a little bit about the future, about how you could use internal waves, the information about internal waves, to generate better, more accurate global climate models. Okay, now with that in mind, I think it's good to just move on to the questions. Let's ignore the graph for now, because let's be honest, if we look at it right now, we're just going to confuse ourselves and forget it. 43. The first paragraph, so we're going to need to go back to that first paragraph, serves to explain a scientific device. Okay, so first paragraph, is there any scientific device? Yes, so there's satellite imagery and some monitoring equipment. But is there anything about how, like, the steps we need to use these? Not really, right? It talks about, the use of it and, how you can't use them to detect underwater waves, the internal waves, but the author never tells us how we could use, actually, let's make it green, blue, never tells us how we could use, how we can learn to use these use these technologies. So A is kind of off topic, right? Doesn't explain how, satellite imagery is used. Okay, B, note a common misconception about an event. Okay, so we need to find a misconception. So that's something that people are confused about or don't understand, right? Okay, not really any misconception right here. I think some people would say that the word impossible to see, or the phrase impossible to see, and I think undetectable, maybe these talk about misconceptions. But the fact that we acknowledge that these are hard things to see and we can't detect them tells us that we're not really uncertain about our inability to detect them. So that's really not a misconception. So hopefully you're not confused and link unrelated stuff together. So B is incorrect. C, natural phenomenon. So we need to find a natural phenomenon and also its importance. Well, straight away, natural phenomenon is talking about internal waves, right? Internal waves. That's going to be our natural phenomenon. But is there something about the importance of these natural phenomena? Well, the word fundamental is synonymous to important, and it talks about how internal waves are fundamental or important parts of ocean water dynamics, and a little bit about what they do, and that addresses, and that's reinstating address its importance, right? It talks about how it's fundamental to ocean water dynamics. So that double check right here, and C is supported by the text. D, present a recent study and summarize its findings. Now, we know that the whole passage, well, most of the passage is about a study, right? It's the research by Professor Peacock. But we also know that all of that starts in the second paragraph. Now, second paragraph and on, where we meet Professor Peacock and all of his research. In the first paragraph, there is none of that. So let's cross D off. So that means C is our correct answer. Number 44. As used in line 19, capture is closest in meaning to. Okay, so let's go to 19. Capture. Okay, it's right there. Capture. Let me capture it. Alright, so let's actually just read a little bit onward to get the context. If you want to have more, okay, climate models, blah blah blah, such as this. So the such as this is talking about internal waves. Okay, let's go on a little bit. Okay, to do just that. Okay, what is to do just that? So to do just that is to capture processes such as internal waves. So now that we know that the next paragraph is going to be talking about capturing processes such as internal waves, we should get a better understanding of how the word capture is used here, right? We know that to accomplish their goal, they published a study. So whatever you're doing here, whatever you're trying to do has to be able to help you, has to be able to be accomplished by describing internal waves in a research paper. So capture has some similar idea to describing and translating that into a research paper or something like that. With that in mind, let's take a look at our choices. Control. All right, so can you control internal waves by describing them in a research paper? that doesn't make any sense, right? So A has to be wrong. B, record. Can you record internal waves, the behavior of internal waves, by describing it in a research paper? Well, yeah, that's basically what a research paper is. They're recording or demonstrating, describing a natural phenomenon and putting it out there in a research journal so everyone can see it. So B seems to fit in the context very well. How about C, secure? Well, secure, how would you be able to secure internal waves by writing about it in a research paper? That doesn't make sense. To secure something, you probably need something like a lock or a chest, right? So let's cross that out. Absorb. And again, you can't absorb internal waves by writing it in a scientific journal. The only way you could probably absorb it is getting tons of scientific journal and just letting the paper absorb the water, but I don't think that's what they're talking about here, right? So D is incorrect. Okay, let's move on to, let's just select the correct answer first, right? No points for no bubbling. Okay, 45. According to Professor Peacock, the ability to monitor internal waves is significant, primarily because, okay, so this seems like a motive, right? This is why they want to study internal waves. So, and we talked about motive in, I think, this paragraph, and also in the future paragraph. Now, what the motive is to be able to create global climate modeling, and similar thing here, global climate modeling, incorporating this information into global climate models. But only one of these paragraphs is talking about what Professor Peacock wants, right? This is kind of like just what the author is saying, and this, like the narrator describing something, and this is directly, said by Professor Peacock himself, the brilliant scientist, right? So whatever we need is going to be here. And it's also going to be about using internal waves, recording internal waves to create more accurate climate models. Okay, now let's see. Any choices that recreate that? A, it will allow scientists to verify maximum heights of such waves. Okay, so that doesn't have anything to do with making climate models, right? And also, we already know the height of these waves, right? Or at least we know how to find the height of the waves, because over here they easily know that their wave is about 500 meters high, and without doing any research, they just arrive there and they're like, oh, 500 meters high, great. So this can't possibly be their motive. B, It will allow researchers to shift their focus to improving the quality of satellite images. Alright, so satellite images is discussed in the text, I think in paragraph 1, right? So satellite imagery, but again, satellite imagery in this case has nothing to do with using internal waves to make climate models more accurate. And the researchers also never say anything like this. You know, there's after paragraph 1, when Mr. Peacock stepped in, he never said anything about satellite images. So even though by our intuition it could be correct, the passage has no such evidence to support it. So that leaves B incorrect. How about C? The study of wave patterns will enable regions to predict and prevent coastal damage. Alright, so we got internal waves and being able to predict. So predict is quite similar to, at least predict is possible using a model, right? But again, unfortunately, in the passage, there's no mentioning of predicting coastal damage. And while just in our own science classes, we know models can help us prevent coastal damages, that's not what the passage is saying, and we don't have any explicit evidence from the passage. So C is wrong. D. The study of such waves will inform the development of key scientific models. Okay, so key scientific models, that seems like a global climate modeling, right? And then we also know more accurate climate models. And anything else? So study of such waves, study of internal waves, to develop more accurate scientific models that make sense. So D is the correct answer. Okay, 46. Which choice? So this is the best evidence. So what we need to do is find the evidence, that led us to choice D. And just for us, we already know that what we used was this paragraph right here, right? So I think this is 11, 12. So from 12 to 19. Okay, 12 to 19. Okay, so this falls between 12 and 19. Let's go see if that will help us. 17 is right here. So if we want to have more and more accurate climate models, okay, that's the scientific model before. We have to be able to capture processes such as this. Okay, so processes such as this, we said that was internal waves. So using internal waves, the study of internal waves to develop key scientific models such as global climate models. Okay, that makes sense. Supports. So C is definitely the correct answer. Now on the actual exam, you probably don't need to go any further, right? You can just move on to the next question. But for the sake of more practice, we're going to do A, B, and D as well. Okay, A, 1 to 2. Some of the largest ocean wave, nearly impossible to see. Okay, nothing to do with climate models, scientific models, so A is wrong. B, 4 to 6. 4 to 6. Instead, they move underwater, undetectable satellite imagery, surface. Okay, so again, nothing to do with climate models, but it does have to do with satellite images, which we know to be false. So cross that out. C, lines 17 to 19. We were just there. Okay. D, lines 24 to 26. 24. So that's around here. Internal waves in this region, thought to be some of the largest in the world, can reach about 500 meters high. Again, nothing that has to do with making climate models or scientific models, so that is incorrect. And also, all of these choices have nothing to do with, except for choice C, have nothing to do with what Mr. Peacock is saying, right? These are all just opinion or statement of the author. So that can't possibly answer something that we need for Mr. Peacock to express. So let's move on to the next question. 47. As used in line 65, device most nearly means. Okay, where is that? Device, right there. Let's capture that device. A different device. Oh well. Okay, let's key. Okay, So what are they devising? They're making a mathematical model. Okay, so this device is similar to making, similar to developing. So something that will help you make a mathematical model. With that in mind, let's see which one of these is synonymous to making and developing a math model. So A, create. Yeah, that seems about right. Let's plug it in and see if it reads smoothly. So researchers were also able to create a mathematical model. Okay, that reads perfectly and fits the definition or the synonym of making or developing. So probably correct. B, solve. Can you solve a mathematical model? That makes sense in another context. We know that this device is developing and solving are two different things. And also solve, you have to have a question in the first place, right? You're trying to solve a math question, and this is a different kind of situation, and where you're trying to make the math model. There's no math question here in the first place, so solve does not fit into the context at all. C, imagine. Okay, let's see. Are also able to imagine a mathematical model. Okay, so imagine is kind of like creating your head or developing it in your head, which could make sense until you realize you're talking about mathematical model, which you need all kinds of data for, and imagine is entirely in your head, and there's no way you could get that data or incorporate any of that data, and just it falls apart from there. So imagine is a bit too idealistic. D, begin, are also able to begin a mathematical model. So begin a mathematical model is kind of like start, right? But we don't see any idea of the project or the model still being in the works of developing. The author didn't say anything about how it's still not made or still not created yet. So we know that begin doesn't fit into the context because of a lack of evidence, right? There's no idea of beginning something in the text. 48. Based on information in the passage, yeah, that's what we're trying to do for every single question. Why did SAT just put it for this one question? It can reasonably be inferred. All right, I don't like that word at all. Inferred. We don't want to infer anything. We want to be very precise about our details. That all internal waves. Okay, so something about internal waves. A, can internal waves reach approximately the same, or do they reach the same height? Alright, so same height. Here's a problem with same height. We know that the losing stride, or where the height comes into play, is 500 meters high, right? But we also know that it's described as some of the highest in the world, and because it's some of the highest, that means there are also internal waves that's smaller than 500 meters high. So what that means is it's impossible for all of them to be about the same height. There's definitely a difference in height there. Okay, B, may be caused by similar factors, but are influenced by distinct topographies of different regions. So we need to find similar factors and distinct. Now distinct, I remember that directly from text. I think it was like distinct structure or something like that. Oh, okay, distinct. Oh, topography right there. Distinct double ridge shape, and also I think there's something about distinct here. Yeah, distinct is specific to losing stride, specific to the distinct double ridge shape. Okay, let's keep going. Is there anything about similar factors? So the idea of distinct was there already. Similar factors, so similar causes. Okay. Okay, so over here, whereas the model is specific to losing stride, it can still help researchers understand how these internal waves are generating in other places. So that means that there must be there are similar factors between them, because otherwise you wouldn't be able to use one specific location to understand how generally they form, right? So this idea of the idea of similar factors is met by this sentence here. So that is a check. So all parts of B are, supported by the text. Let's leave that open. C can be traced to inconsistencies in the tidal patterns of deep ocean water located near the island. What the crap is this very complex answer choice? And unfortunately, well, luckily for us, none of this is, even related to the passage. I can't even go back to disprove it. It's just kind of outside the scope of it, so easily cross that out. D are generated by the movement of dense water. Okay, dense water relatively. Okay, so the idea of generating makes me want to go back to, and dense makes me want to go back to the conclusion. That's where they found out how these waves are generated, right? So, okay, dense. I even underlined it. Nice. Dense water. So dense water is pushed over warm water. So dense, cold water pushed over warm, less dense water. And then here it's dense water are generated by movement of, wait, hold up. Oh, no. I don't think that's the relevant part. So dense water is pushed over ridges. Okay, ridges. That's what I was searching for. So ridges are not flat sections. So we have a contradiction right there, right? So that means D is incorrect. Okay, which choice, is the best evidence? So what was the evidence we used to find choice B? So I think it was something over here, right? So specific, so that's the specific distinct topography, and then over here is the generating other places, which is talking about the similarity between internal waves. So it's going to be a sentence in between 65 to 75. Is there anything there? 60. Okay, so this one falls right there. 67. Okay, yeah, that's the sentence we were just at. So that makes D the correct answer. Okay, C. Oh yeah, again, also I want to remind you that you definitely won't need to go back and look at A, B, and C during the actual test. But right now, I just want to get more practice in for you guys. So C, lines 61 to 64. 61 to 64. As these waves move toward land, they become more steep. Okay, so none of it is relating to similar factors and different topography. So that makes this incorrect. How about 56 to 58? 56 to 58. Okay, here, as tides rises and falls, water colder, denser. Okay, so this relates to which one? Right? Relates to this, right? Talking about the dense, cold water. But as we know that this flat section is contradicted by the steep ridges in choice, described by choice B here, and there's like this, so this wouldn't support choice D at all. It actually contradicts part D, so choice D, so B has to be incorrect. How about A, our last choice here? 29 to 31. 29 to 31. 29 to 31. Okay, so although didn't know how ocean waves form. Okay, so again, has nothing to do with both similar factors or distinct topographies. That was a bit about how, that was more of a question, how internal waves formed, and this is more just a statement of we found that these are similar factors and stuff like that. So A is incorrect, kind of in a different direction. Okay, number 50. in the graph. Okay, so now that we see in the graph, we go look at the graph right away. So because we want to kind of break down the terminology here, right? So changes in depth of isotherms. What are isotherms down here? Okay, bands of water of constant temperature. So changes in the depth of bands of water of constant temperatures in an internal wave over a 24-hour period. Okay, let's go back. Okay, which isotherm diagram displays an increasing depth below the surface during, okay, so 1912, 2024. Let's go mark it right away. 1912, right here. Oh, they're right next to each other. Okay, great. So 1912, 2024, and we want an increase in depth. Increase in depth. Let's just kind of mark it here a little bit. Okay, so this one went from, I think, maybe 25 to 40. So 25 to 40 depth meters under the ocean. So that's an increase in depth, right? So I think this one is going to be the right one. How about this one though? So this went from 80 to 60. Okay, from 80 meters under the sea to 60 meters under the sea. That's definitely a decrease in depth. So this one's incorrect. And we see that the following choices have similar slope. It's going both upward, right? So they also are increase in, decrease in the depth. Okay, so all of them are wrong. And that one is 13 degree. Okay, there we go. 51. Which concept is supported by the passage and the information in the graph? Okay, so for this question, we have to find something, that's both in the passage and in the graph. And usually the graph is going to be the more limiting factor, okay? Because there's just certain information that you can't tell from just data. So usually we're going to be using the graph to eliminate answer choices. A, internal waves cause water of varying salinity. Okay, right away we see salinity. And we know the graph has nothing to do with salinity. It's not in the title at all. Okay, so A can't be right. Internal waves push denser water above layers of less dense water. Okay, density, right? Density is not a factor in the graph, right? So that can't be right. C, internal waves push bands of cold water. Okay, cold water, warm water. Yeah, we got that. We got temperatures here. But is that supported by the passage? So we got cold above warm. Okay, cold above warm. Cold above warm. Okay, so here's the temperature. Cold is pushed over warm. Wait, what? Cold internal waves push bands of cold water above bands of warmer water, and then we see that colder dense water is pushed up the ridges into the warmer, less dense layers above it. And we see that contradiction right there. So C has to be incorrect. Okay, D, internal waves do not rise to break the ocean's surface. Okay, well, do we see anything about internal waves going over the surface? Well, no. None of it goes, in the negative, right? None of it goes above 0. So that's supported by the graph. And also, we know the passage said that, well, in the definition of internal waves, it's just waves under the ocean, right? So that they can't break the ocean surface. So that means D is supported by both the passage and the graph. Okay, next, the very last question, 52. How does the graph support the author's point that internal waves affect ocean water dynamics? Okay, A, it demonstrates that wave movement forces warmer water down to depths that are typically colder. So, okay, warm water needs to go to places that are usually colder. Okay, let's see, graph. Okay, so 13, 11. Okay, so the top one is the hottest, and the one at the bottom is going to be colder. Okay, so do we see any example of warmer water being in places where the cold water is? Well, pretty clear that right here is what we need to find. So this warmer water is going into depth where the 11 degree was, right? So this is like kind of like where the 11 degree is, and this hotter one is going in there, and then the same case is happening to the 11 degree as it intrude into the 10 degree zone, right? So at the start, the 10 degree right there, and then right there. So we see a perfect example of choice A. So let's leave that open. Okay, B. It reveals the degree to which an internal wave affects the density. Okay, density. Great. Cross that out. This is really off topic here. SAT is trying to trick us. C. It illustrates the change of surface temperature that takes place during an isolated series of deep waves. Oh shoot, series. Alright, so that is something that we got to be careful about. We know that our wave is just one internal wave, and it's not a series of internal wave, right? And also we don't know if it's isolated series either. So that means C is incorrect. D. It shows that multiple waves rising near the surface of ocean disrupt the flow of normal tides. Alright, again, multiple waves, so kind of like that series as before. And we know our graph is talking about just one internal wave, so choice D also has to be incorrect. That leaves A to be the correct answer choice. And I would go on, but SAT just told me to stop, so I think we should wrap it up for this episode of SAT madness. Well, if you have any further questions about any of these answer choices, please feel free to leave it in the comments below. I will definitely come over and help you out. And if I don't, someone nice, another student in the comment section will love to help you out as well. And if you find any of my techniques or explanation useful in raising your SAT score, then feel free to like and subscribe. Anyways, I hope you guys the best, and go get that 1600, right? See ya.